It's the Cozy Rainbow Podcast time.
Hi, everybody. Welcome to the Cozy Rainbow Podcast. My name is Tammy, but my students know me as Miss Tammy.
My name is Joe, and I'm partial to Aurora Australis.
On today's episode of the Cozy Rainbow Podcast, we're talking about Aurora Borealis, which is the northern lights.
Australis is the southern lights.
Which we'll find out later on in the episode.
Yeah, I thought it was being clever, bringing something unexpected, but no, she got me.
No, it's great. The listeners will just hear it twice, and maybe they'll be more likely to remember, and one day it'll be like a Jeopardy question, and one of our listeners will win Jeopardy. And anyway, let's get into the trivia questions. Number 1, multiple choice. Aurora Borealis takes place in which of Earth's atmospheres? Okay, we have A, the thermosphere, B, the mesosphere, C, the stratosphere, or D, the troposphere.
Is that in order of altitude?
That is a good question.
Wow.
That's a good question.
If I'm remembering right, no, actually I don't remember right. Never mind. I don't know what I'm talking about.
Okay, you know what though? Let me look, because listener, if you're listening, on the web page of this episode, I did make an image. Like, there's a graphic image that you can view. Do I have it up in front of us right now? No.
Alas, I'm stuck in podcast land. I am but a voice.
Yeah, we can't. But you can go to cozyrainbow.org, and there's a picture on this article.
Anyway, so going purely by the names, I like mesosphere.
Okay. If we were to assume that they were in order, which one would you? I guess we don't. Okay, sure.
I'm just going by the name.
I love this. I love this carefree Joe for once. Okay, number 2. You might know this one. Which planet has the strongest magnetic field out of these ones I'm about to name?
Oh, oops.
A is Venus, B is Mars, C is Earth, and D is Jupiter.
Jupiter's pretty big, you know.
I do know.
Big things tend to have pretty strong forces on them.
Mm-hmm.
Like
Yeah.
me. I'm pretty big.
Okay. And number 3. The next question is a true or false. Number 3. True or false, the northern lights are only visible in cold regions that are close to the poles, like Canada, Alaska, and Antarctica.
Well, as I am unaware of any regions that are near the poles that are warm, I'm going to have to say true.
Oh, okay. Yeah. Well, there are not any regions near the poles that are warm.
Yeah.
That's kind of the whole point.
Yeah.
The polar weather. Okay. We're going to get into the answers to those trivia questions and even more fun facts about Aurora Borealis.
More like Aurora Borealis.
What? No.
Hey.
It's somewhat interesting, if not very. So, yeah, right after this break. The Aurora Borealis, commonly known as the Northern Lights, stands as a celestial masterpiece that has intrigued the human imagination for centuries.
Isn't Aurora Borealis like a straight, like if you translate it from Latin, it's literally just Northern Lights?
Probably. You know, for once I didn't look up the origin of Aurora Borealis because I just was going to call it Northern Lights for the most part.
I mean, yeah, the science is probably a lot more interesting than the linguistics.
Well, hey, we get into all of that stuff on Cozy Rainbow.
Yeah.
The display of the light in the night sky is both beautiful and intriguing, concealing within it the secrets of cosmic interactions. Let's journey into the heart of the Aurora Borealis, exploring the science, geography, and fascinating lore surrounding this awe-inspiring phenomenon.
Lore, we're talking mythology?
A little bit.
Oh.
Okay, so first we're going to get into the science. So the northern lights are born from the collision of charged particles from the sun with Earth's upper atmosphere. So charged particles plus Earth's upper atmosphere equals Aurora Borealis.
You know, I could ask what kind of charged particles, but I feel like that's a little bit beyond the scope of what we want to talk about.
Exactly. Yeah, we're not going to talk too much about those charged particles today. Just know that they are.
The sun has them, and it gives them out like candy.
Well, you can imagine, I mean, they're charged with heat, like the sun's heat energy. So I don't know. And, science can be pretty mysterious anyway. So who's to say?
If you want to know more about this, go be an astronomer.
Yeah, go get a PhD and do some research on it because it's complicated. Okay, so those charged particles move up to 45 million miles per hour. The charged particles are guided by Earth's magnetic field toward the polar regions, where they create a mesmerizing atmospheric display. The particles interact with the atmosphere and they deposit energy into the atmosphere. So those charged particles, they have the energy from the sun, okay? And they travel through Earth's, magnetic forces. And yeah, then it gets into the sky, puts energy into the sky, and that causes the fluorescence and it produces vibrant colors that define the aurora. Solar winds, composed of those charged particles, they play a pivotal role in this cosmic ballet. Our planet Earth has 5 atmospheric layers. Here we are. Oh, what? I don't even name them in the article. Are you joking? Okay, there's 5 atmospheric layers, and I guess you know what? The only one that you need to know right now is the thermosphere. The northern lights happen
because it's the sun, and the sun's hot, and the I get it.
Oh, yeah, sure. That's one way to do it. The thermosphere, like your thermos that you brought for lunch today that's keeping your lunch warm. So within the thermosphere, though, there's the atmosphere. I mean, it just is the atmosphere, right? You can break it into however many layers you want. Most scientists agree on 5, but technically it's in a sub part of the thermosphere called the ionosphere.
Named after those charged particles. We got to it eventually. They're ions.
Yes! I love your science brain, Joe. Thanks for being here. And thanks to Earth's magnetic field, we are protected from those solar winds that I mentioned. Now, would you like to get blown some solar winds in your face? I imagine they're hot.
The sun's pretty strong, and it's got a lot of radiation to throw at things, so I'd rather not.
Yeah, so that's why we have Earth's magnetic field. The clash of the magnetically charged particles from the sun and the ionosphere initiate the birth of the aurora, transforming the night sky into a canvas of dancing lights. The Aurora Borealis grazes the northern hemisphere, while its southern counterpart, the Aurora Australis, dazzles observers in the southern hemisphere. I thought you were going to finish my sentence there, and you didn't.
You're the one with the facts here.
No, you came with that fact.
I did, but I already had my we're sharing the ability to talk about the Aurora Australis.
It's true. All right, next we're going to talk about where the Aurora Borealis gets the colors.
Well, that would be the north.
Okay, either of them, where the colors come from. So the kaleidoscopic hues of the aurora are a result of the chemical composition of Earth's atmosphere. Each atom or molecule, be it an atomic hydrogen or carbon dioxide, emits a unique set of colors. Nitrogen and oxygen are responsible for the blue and red hues in the aurora's lights. The altitude can also determine the color of the lights. So red light that you see is closer to the Earth and green is further away. But when I was looking at a picture of it, actually, I think it's more like a sandwich. It's green, red, green.
Oh, like a rainbow.
A
real rainbow of colors. A real palette of
sky colors.
Watercolors, I don't know.
Sky watercolors? Ionic colors.
Water isn't literally involved, but watercolors is a pretty apt way to describe it.
It's more, I guess that would be visually how to describe it rather than scientifically or elementally.
Yeah.
Yeah. Okay, now we're going to get into the history of the Northern Lights. Even though the Italian astronomer Galileo Galilei named them the Aurora Borealis in 1619, connecting it to the Roman goddess of dawn and Greek god of north wind. The Northern Lights actually have a much older history than Galileo. There's a cave painting, your fave, in France that's estimated to be about 30,000 years old.
Is it in Lascaux?
I bet you it is. And it's thought to be the earliest depiction of these captivating lights. So once again, incredible discoveries from cave paintings. Go listen to the cave paintings episode if you
Cave
haven't.
folks were pretty smart, you know.
The cave folks.
They knew how to look at things and represent them in their art
Yeah.
in caves.
Yeah, that's right. Little sketch artists. So throughout history, people from different parts of the world have gazed at the sky, mesmerized by the celestial dance of the Northern Lights. Various cultures created imaginative myths to explain this phenomenon. For example, North American Inuit people believed the lights were spirits playing with a walrus head, while Vikings thought it was the reflection of light off the armor of the Valkyrie, mythical maidens guiding warriors into afterlife.
Those are both very apt for those two cultures.
What do you mean apt?
Well, the Vikings say it was armor,
Yeah,
and the Inuit say it was
a walrus.
fun times.
You go. Oh, yeah.
Yeah.
You go with what
it's
you know.
apt.
Yeah, okay. All right, yeah. You go with what you know. And let me also just say, I didn't know what a Valkyrie was until this. I just thought it was like a video game thing. Did you know?
Very few things are original.
Well, I didn't know like what the original like. Well, hey, you know what? Who's to say this is the original like Valkyrie? But I'm just saying I didn't know like.
Yes, the original Valkyries are in fact from Norse mythology.
The more you know. Good job, Joe. Okay. And that's the lore. But okay, we're actually not done with the lore. Early astronomers also documented the Northern Lights in their records. A Babylonian astronomer.
Oh, Babylon. I remember that one. I talked about that one too.
Oh, yeah?
Go listen to Zodiacs.
Oh,
Or
yeah.
Go listen to the Zodiac.
The Zodiac episode. Yeah, that one's called Earth Wobbled, and now there's an extra star sign.
And now it was always there.
Well, I was trying to make it sound like shocking, but I think I could have just mentioned Ophiuchus, and I think that would have been shocking enough. Okay. So, yeah, there is a king, and oh my gosh, I don't know. I don't think I can say this name.
Spell it.
Nebuchadnezzar.
You lost me.
Yeah, exactly. Nebuchadnezzar.
Well,
Nebuchadnezzar.
finish
the
spelling
second.
it for the people listening.
It's okay. You can follow along with our episode transcript.
Yeah, or you could do that.
Yeah, on cozyrainbow.org. If you're a teacher, find it on Teachers Pay Teachers. Okay, great.
If you speak the language that this name hails from, help
Babylonian?
us.
Help us. Okay, yeah. Anyway, so this king, no, the astronomer under the king wrote about those lights. So all you need to know is that it was a Babylonian astronomer. During the year 567 BC, they found a mention of the lights during that time. And then also in a Chinese report from 193 BC. It's weird. It's hard to say these years. They don't sound real, but they were. And that's how long the aurora has been around. Can you imagine? I think it must be so... I've never even seen these lights, okay?
Now, strictly speaking, I'm pretty sure they've been around for a lot longer than Babylon and China.
Oh, silly Babylon and China. Yeah. Okay.
You know, considering the cave paintings.
30,000 years ago?
And probably before that. I mean, what...
Long before humans existed,
Before-
there were ions.
There were ions, and then there's also an atmosphere to make the Northern Lights.
You would think, but how can we really know?
I there's like
Oh,
the physics of making the Northern Lights. Like, it's not going to change, right? As long as there's an atmosphere and solar winds, they're going to happen, like, near the poles and stuff.
yeah.
So really, we can assume that the Northern Lights started when there was an atmosphere, which
We don't know when that was.
I could
We
we
can
just went over this.
hypothesize.
Just
Joe's
went
like,
over
just
this.
give me a second. Let me contact my spirit guides and ask them.
What?
No, just kidding. That's me. I would do that. Joe's actually going to look in his textbook, conduct an experiment.
Okay, I don't actually know like that, like when gas started like floating around Earth, when we started having a little bubble of gas around us, but I do know when it started being mostly oxygen.
Okay, when?
I forget the
He's like-
number.
He's like, I know it.
I forget the number,
doesn't
but it has to
know.
do with cyanobacteria and photosynthesis, and don't worry about it, all right? But I know.
Okay, great.
I know
So,
that it exists. The
yeah.
point happened.
Yeah, it happened. And Aurora Borealis is probably
Was
been
also
around
there
since
when
then.
it happened.
Yeah, and who knows? Maybe it was around before then, and the colors just look different because of the oxygen. You know what I mean?
Yeah.
Yeah. Okay. So, wow, that was a tangent. We talked about, that was about Babylonia, right? That's why we got off. So, the scientific understanding of the Northern Lights didn't emerge until the early 20th century. Norwegian scientist Christian Birkeland proposed a theory around 1917, suggesting that electrons emitted from sunspots created these atmospheric lights, guided toward the poles by Earth's magnetic field.
No, that's a smart cookie.
Yeah. So, okay, let me read that sentence again and break it down because that was a very long sentence. So, the electrons emitted from sunspots create these atmospheric lights. So, are electrons ions?
No.
No.
Ions are just like atoms, but with a charge. Electrons are what give them electrons are tiny particle things that, for all intents and purposes, are electricity. Right? When electricity is running through your wires, it's all the atoms of the wires passing around the electrons really quick.
Okay.
So like the sun's shooting little electric particles out from sunspots
Yeah.
at us. And those electrons curve around the Earth and are driven to the poles by, magnets. They're like
mysterious
magnets.
magnetic forces.
Electricity and magnets are very closely related, you see. She gave me this look. I don't know what to make of it, but she seems like she's gonna laugh.
I'm just like flabbergasted because you just know so much about science.
Well, they call it the electromagnetic spectrum, you see. See, electro and magnetic in one word?
Closely related.
They're quite closely related.
Okay. So yeah, that was Birkeland was thinking. Good job explaining that, Joe. While Birkeland's theory was ahead of its time, it eventually proved to be correct, marking a significant milestone in the unraveling story of the Northern Lights.
Ahead of its time, as with all great scientific theories and discoveries,
Yes.
No one believed it at first.
Yeah. Yes. So you hear that, scientists? Young scientists, if you have a crazy theory, you could just be ahead of your time. Next, we're talking about where you can see the Northern Lights.
That would be the north.
Well, while the auroras are more frequent at higher latitudes? Yeah, latitudes.
Yeah, as opposed to longitudes, which is horizontal.
Yes, no, I just was thinking for a second, I was like, is this supposed to say altitudes? I never realized altitude and latitude are just two switched, the A and the L are switched. Okay. While the auroras are more frequent at higher latitudes, their ethereal glow has been witnessed at unexpected locations closer to the equator, including Mexico, on one special night in 1958.
That's a pretty low latitude.
Yeah, it's close to the equator.
Yeah.
Yeah.
That's kind of nuts.
It is, yeah. So the optimal viewing spots, yes, are in those regions like Alaska, Canada, and Antarctica, situated closer to Earth's poles.
But how do you know if it's northern lights if you're at the equator?
Oh. That's next level questioning. I don't know. Well, actually,
I guess they'd be like
no, it would be
northward
facing
from-
north. It would be facing north. Now, no, yeah, okay, whatever. Auroras can be visible year-round, but the key to this to observing the northern lights is darkness. Nighttime sightings are enhanced in locations with minimal light pollution. Also, I thought I put this in here, but I didn't. So that night in Mexico, it was just happening to be this. Oh, no, I'm going to get into it later. But it was happening to be a time when there was like a huge solar flare or something. Like the sun was like going crazy, shooting those.
Oh, so there's okay, so you can't just walk out any old night in Mexico and be like, oh, look, it's
Oh,
the
no.
Northern Lights.
No, this was a special night in 1958.
Well, the sun was big windy.
Wilden. Yeah. Okay.
What did you say?
Wilden?
Yeah.
You never heard that?
Is it a word that you would use to describe the sun?
Yes. Like the sun is like wilding out, like going crazy.
All right, I guess.
Yeah. Okay. Next, we're going to talk about auroras and Earth's upper atmosphere. So, auroras provide valuable information about the Earth's upper atmosphere, giving insights into its density, makeup, flow speeds, and the strength of electrical currents. These details, in turn, help us understand the Earth's magnetic field, how far it extends into space, and how it changes over time. This knowledge is crucial for safeguarding Earth and space technologies from the potential risks of space weather, in which the aurora can play a role. Kind of like when you're at the airport. Oh, actually, you know what's funny? Joe's never been on a plane. So you wouldn't relate to this, but it's kind of like if you were on a plane and there's like, wait.
And there's turbulence and you get really scared. Oh, no.
No. Not even turbulence. If there's bad weather and then your flight gets canceled.
I thought you said on a plane. Like
Well, if you're, I guess I should have said if you're trying to get on a plane and you haven't gotten on yet.
Yeah, I haven't been on a plane too. I haven't had a flight canceled on me, but I sure haven't been on a plane. Yeah.
Okay.
So maybe I can relate a little better than you think.
You can relate. Okay. Although the solar wind is always present, the sun's activity follows an approximately 11-year cycle. This cycle includes periods of calm and other times of intense storms, bombarding Earth with its high-energy particles. During these stormy periods, the northern lights shine the brightest and occur more frequently. So,
the sun operates on a cycle. It has stormy periods, like your 3-year-old cousin.
Yeah. So that explains that time in Mexico, and there's other times too. So fortunately for those fascinated by auroras, we are currently approaching the solar maximum, expected to reach its peak between early 2024 and late 2025. And actually they updated their forecast, so the solar maximum might take place between January and October 2024.
Hang on. Right now is between January and October 2024.
Yeah. Well, this was written in January and it's February. I guess this might not get posted till March.
That's still in between.
Yeah, no. So yes, like it's
That's
going
right now.
Right now.
As of time of uploading,
So
dear listener.
go ahead and look up right now in the sky. Is there northern lights? Take a picture if there is. And then send it to us. Okay. While scientists cannot precisely predict when the solar maximum is going to happen, we know that it is coming. The end. Now we're going to talk about northern lights and other celestial bodies. The enchantment of auroras extends beyond Earth, reaching other planets with atmospheres and magnetic fields, dun, 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 like Venus and Mars. But Venus and Mars have comparatively weak magnetic fields. They do have their own version of an auroral phenomena. And big old Jupiter, boasting a magnetic field 20,000 times stronger than Earth's, dazzles with auroras fueled not just by solar winds, but also particles released by its volcanic moon, Io. Is that how it's pronounced? It's literally Io.
I've heard it said Io a lot.
Io, yeah, but that might be a different moon.
If it's Io, it's Io or Io, and I've heard Io more often.
Okay. I'm with you.
But Io is also valid, right?
I mean, it's literally spelled I-O. So anybody who says, oh, it's not pronounced I-O, it's pronounced E-O. I'm like, come on. What do you mean?
Uranus, who cares?
Yes. You know what? Thank you, Joe. Next, we're going to talk about forecasting and viewing. The auroras are inherently unpredictable, yet advancements in satellite technology enable scientists to measure solar wind conditions, offering some forecasting ability. The best viewing times are typically from August through April, with peak months being in October, November, and April. Dark, clear nights enhance visibility, but the nature of the auroras means that patience is key. The northern lights may grace the sky only for a short time, underscoring the importance of being prepared to capture these fleeting moments. I'm going to leave you with some fun facts. So, the term Aurora Borealis is credited to Pierre Gassendi and Galileo Galilei in 1621, but observations of the auroras still date back thousands and thousands of years.
Right. I know Galileo, but who's Pierre? Huh? What was his last name? Pierre what?
Gassendi.
Yeah, Pierre Gassendi. Yeah, who is that?
Well, we're not getting into that today. We just talked about Galileo briefly. So that'll be something else to look into one of these days. My next fun fact for you is these celestial displays can reach astonishing heights of up to 620 miles with increased frequency during periods of high solar sunspot activity.
Now, did someone grab their tape measure and measure the aurora? Or was that just like physicists mathing it out?
Again, that's like a really big question. I'm sure that's like scientifically accurate. I don't think they have a measuring tape. Yeah. So I wonder how they do that though.
Yeah.
Okay. Legends from northern cultures abound, attributing the aurora to mystical powers, with some warning children of the light's potential to come down and snatch them away.
There are a lot of things at night
Yeah.
that could come down and snatch you away.
Anything to scare kids, right? It seems like that's a lot of the like cultural stories are like, watch out, kids. You know, like Hansel and Gretel, or like, what's that German one? Krampus. Okay. Anyway. This one's fun. The International Space Station is located in Earth's ionosphere. Remember what happens in the ionosphere, Joe?
Oh, so they just can't see on a bad night. The lights are just the neighbors are partying too hardy. The aurora is just blasting through their windows. They can't get any sleep.
I guess that could happen, but I was just going to say that astronauts get to see an eye-level view of the aurora. And there's a picture on NASA's website.
So they're the ones who broke out the tape measure and measured it. I see. Okay, it all makes sense now.
Oh, actually, yeah. So there you go.
Oh.
My last fun fact is that the Northern Lights were once visible from Mexico City, recorded in 1958. I know we already talked about that, but it is super fun. So with that,
Especially for people in Mexico.
Mexico City.
As we gaze upon the Aurora Borealis, we witness a celestial symphony, a dance of charged particles, magnetic fields, and Earth's atmosphere. This captivating phenomenon transcends geographical boundaries, inspiring awe and wonder across cultures and generations. The Northern Lights, with their vibrant colors and dynamic displays, invite us to contemplate the intricate connections between our planet and the cosmos. In the vast expanse of the polar night, the aurora continues to cast its enchanting spell, encouraging us to marvel at the beauty and complexity of the universe.
Lovely. Wow. Let's go back over the trivia questions. Number 1, Joe. Aurora Borealis takes place in which of Earth's atmospheres?
The ionosphere.
Yeah, but that was
the thermosphere.
Good. It's both. Because the ionosphere is inside of the thermosphere.
Yeah.
Cool. Good. Okay.
So I was always right.
What?
Except for the first time when I said mesosphere. But after that, I was
Yeah,
right.
yes.
Always. The whole time.
The whole time. Number 2, you were right the whole time. What planet has the strongest magnetic
Jupiter.
field? Jupiter. Yeah, okay. Don't even let me finish the question. How about that?
Planet X in the Kuiper Belt.
Okay, number 3.
I don't even know if it's still called Planet X, but whatever.
Okay. I didn't even think that was real, what you just said, but I guess it is.
Do you think there aren't planets outside the solar system?
No, I mean, I guess I didn't think about it. Okay, number 3, true or false? The northern lights are only visible in cold regions that are close to the poles, like Canada, Alaska, and Antarctica.
False.
False.
Sometimes.
Yeah, because it can happen in Mexico City or places that are close to the equator if the sun is wilding out and having solar
Wilding?
flares. I shouldn't have said that twice because that is slang. So the sun is...
Big windy.
Okay.
Come on.
When the sun has a lot of solar winds and a lot of charged particles and solar flares, and what was the other word? Is it sunspot? Yeah, sunspot, when there's sunspots. So anyway, I already promoted the website in this episode, but
If you want to look at all the words that we couldn't pronounce this episode,
Oh, yeah.
please take a look at the transcript,
yeah.
or the transcript. This the
Yeah, we
notes
put
of
out
it.
we put out some scaffolded notes for you to follow along. I do a little map for you to mark the different locations that we mentioned in the episode, and you can even fill out your very own timeline of all the dates that you heard in this episode. So if you thought everything that we said was super confusing and it was a lot of information, you are right. And that's why I provide graphic organizers for you to learn from at cozyrainbow.org. If you have like a message or like, I don't know, something you want to share with us, you can email us at cozyrainbownv@gmail.com. All right, everybody. Thanks for listening.